Tell us your name and tell us about your project. My name is Clinton Davisson, and I'm involved in the Davisson-Germer Experiment, which is related to the wave nature of electron. And our main experiment purpose is to see how electron beams diffract off of different surfaces of different types of materials. What were you guys trying to do or find? Our original purpose of the experiment was to study the surface of different types of metal. In this case, we decided to use a nickel. And we wanted to see how, if we were to shoot electron beams at this metal in one direction, to see how the electrons would diffract off of it, whether it be multiple directions, multiple angles, or just one straight beam. And to see how, if we were to adjust different types of voltages of the electron beam towards the surface, and to see if that would affect a greater span of which way the electrons went or what direction they traveled. Where did the project or experiment occur? When we were looking for a place to do our experiment at, it was a no-brainer for me to have it done at my home laboratory at the Bell Labs in West Village, New York, where I have personally witnessed from my lab chair numerous breakthrough experiments occur. What other significant events were happening around the world at that time? You can say that when we were about to perform our experiment or prepping for our experiment, that we were under some pressure to either prove or change many of the theories or experiments that have already occurred before us. The really big one happened in 1924. Louis de Broglie experimented and theorized that wave nature of electrons and all matter have wave properties. He also did prove this through shooting beams of electrons at different items and see how they diffracted. And after multiple attempts and multiple items, he was able to practically, in our sense, in our physics sense, to say that he has theorized and confirmed that electrons do indeed have wave properties. And this created a groundbreaking thesis for quantum theory and quantum mechanics as a whole. Who else was involved in the project? Of course, this was a big undertaking and a big project to do by myself, so I brought along my lab partner, Lester Germer. He has been a lab partner of mine here at Bell Labs for many years, and also is very much interested in wave mechanics and seeing electrons do indeed have those properties. He was also interested in proving or confirming or creating a new theory or possibly a groundbreaking experiment that could create a new theory that would affect quantum mechanics as a whole. What was your role in the project? Of course, my role I did not take lightly in my experiment because my name's on the experiment. I wanted to closely mimic as possible the conditions that de Broglie used, but then again, I also wanted to change many aspects that can create multiple different results. But surprisingly, we altered our apparatus in enough sense to me and to my partner Lester Germer to figure out that we can possibly prove a different kind of theory. So in reality, we went ahead and changed everything we could, but also kept the same idea that de Broglie had, and we wanted to see what kind of end result we would come up with. What impact did your project have on the physics community? After we prepped for many months and constructed our experiment, we were excited to test it beyond all belief. It consisted of a vacuum apparatus that was to measure the energies of electrons scattered from a variety of metals and surfaces, which in our case was nickel. We, of course, used different voltages of the electron beams to see if that affected the diffraction in a bigger or smaller scale. After completing our experiment, we looked very hard at the results and found more answers in the questions we asked ourselves, which is never a bad thing for science and its development. In this case, we were able to confirm off of nickel that electrons as diffracted off of the surface creates wave-like properties in multiple directions. And this, fortunately, did indeed confirm Louis de Broglie's experiment, which indirectly says that electrons have wave-like properties, creating an important development in quantum mechanics. So our experiment personally directly affected his experiment in that we confirmed his theory that electrons do indeed have wave-like properties. Did this particular experiment spark new or confirm developments around electron intensity and wave-like properties? Of course, there's the experiment of Louis de Broglie, which indeed theorized that wave properties are in electrons. And thankfully, unfortunately, we were able to help him out in confirming that, but we also did indeed discover more about how voltages did affect electron beams, and that the more electron power we put towards it with a higher voltage, of course it diffracts in bigger fragments and bigger waves and bigger angles, but it still contains and keeps that wave property almost directly compared to Laborie's experiment. So although were able to confirm that, we were also proud to say that our experiment was successful in our eyes, and that it did indeed diffract off the nickel and went in multiple directions and consistently had wave-like properties throughout. And with that result, we are proudly able to say that our Davisson-Germer experiment in our eyes went very well, and that we are hoping that this sparks new movements in quantum mechanics and quantum theory, and that we were able to continue and experiment more in the future to keep theorizing and welcoming these new ideas and new theories to the basics behind physics and quantums.